Woo-hoo-hoo. We're going to continue with some limits here. Some more graphs. But now if you notice that graph in example 1, oh, whoa, there's a little jump there, right? Okay. So one-sided limits. What is a one-sided limit? So a one-sided limit is the y value a function approaches as you approach a given x value from either the left or right side. Okay, so let's take a look here at this first example. It says the limit of f as x approaches 3 from the left-hand side is -1. That means as you're coming down this graph from the left, kind of fell off the graph there. There we go. My y value is -1. Okay? So as x approaches 3 from the left, and the way we notate that is with a little negative up top there, a little minus sign up top. The limit of f of x as x approaches 3 from the left is -1. And that's the notation right there on the right-hand side. So we got our nice limit notation on the right, what it means in words on the left there. Now, on the flip side, we'll go with actually go with the lighter blue. The limit of f as x approaches 3 from the right-hand side. So as I'm coming on the right-hand side here, I am going to +2 for my y value. So as x approaches 3 from the right, so I'll put a little positive sign. I'm coming from the positive side of 3. It approaches +2. Okay? So I'm looking at it from the left and from the right. I can't remember if that flips me around on there. Hopefully my hand movements make sense. Okay. Anywho, let's continue with some examples, shall we? I think so. Oh, hold up. If the two sides are different, almost missed that question there. If the two sides are different, what do we think that means? Well, I have no real decision here, so let's see here. The limit of f of x as x approaches 3, just 3 in general, not from the left, not from the right, but the limit as x approaches 3. It's approaching two different things. Can you really make a decision as to what it's approaching then? No. So it does not exist. So as we saw in some previous ones, if the limits are the same from the left and from the right, in the previous video there, as I talked about, it approaches the same thing from the left and from the right, you actually do get a limit. But when it's approaching two different things from the left and the right, the limit does not exist. All right, I think I've said that enough. Let's move on. Example 2. So we've got this wonderful graph on the right-hand side here, and we've got 9 different questions to answer. So let's work through them. So for the first one here, we have the limit as x approaches, and I like some of these, maybe like red because it shows up on the graph nice. The limit of f of x as x approaches -2 from the left. So from the left-hand side, so I'm looking at this stretch here, what am I approaching? I'm approaching +1. And that's from the left. Now, from the right, which is the next question here, right? As the limit of f of x as x approaches -2 from the right, that's what that little positive means. I'm on this side of the graph, on the right-hand side of -2, and I am approaching -2. Lovely. So part C here says, what's the limit of f of x as x approaches -2? Well, since from the left it's approaching 1 and from the right it's approaching -2, I'm not approaching, the limit does not exist, right? I'm not approaching the same thing, so it does not exist. Okay. Part D, the limit of f of x as x approaches 1. So we'll still just ask general ones of those like, hey, what's the limit as x approaches 1? You need to check, is it the same from the left and from the right? So from the left, as I approach 1, it's +1. From the right, it's also +1. It's approaching the same thing from the left and from the right, and that value happens to be +1. I could have just straight up asked question C here to start, and you would have had to have come up with the does not exist on your own. You're like, oh, it approaches two different things from the left and the right. Does not exist. Okay. The limit as x approaches 0. The limit of f of x as x approaches 0. Well, it's approaching -2. There's a terrible arrow there. -2 from the left and from the right. So -2 would be my answer here. All right. Cool. The limit of f of x as x approaches 3 from the left side. So it's approaching +3 from the left. That would be right up here. Whee! Boom, there's my x value of +3. What's my y value? It's 5. The limit of f of x as x approaches -1. So what is it when it's approaching -1? And that's from the left and, so it's just -1, right? From the left and from the right, so they have to agree for it to exist. It approaches 3 from the left. Sorry, -3 from the left, -3 from the right. So -3 would be my answer. Okay, now we're not talking limits. We're just talking function value. What's f of 1? F of 1 is not this guy right here because it's a hole in the graph. It is that one right there. So I'd have -2 for my answer. And I want us to take a look at f of 1, and there it is. The limit of f of x as x approaches 1. They're two different answers. And if you recall from previous videos, that can happen. Okay, that can happen. So we have a hole in the graph, and then we have that point elsewhere. So the function value is different from the limit. That's okay. It's possible. Okay. That will have different implications later on. We won't jump to that now. F of -2. Well, f of -2. All right, again, I've got two different spots here. Well, it's not going to be the hole, okay, because there's no value there, but it is +1. Dunzo. First example. Whew. That's some good stuff right there. All right, now this next one is a bit tricky. We have to draw the graph based on all this information. Okay, these are tough. So I want you to pause the video here for a sec. Try to think of a little bit of a game plan here to see if you can, where would be best to start, what certain parts might look like, and then we're going to have to piece this whole puzzle together. These are definitely the most challenging problems to do. I mean, the challenge, even once you've done a few of them, they're still very tricky. So we're going to take our time with this. So hopefully you took a little bit of time to kind of think through this and how we might go about it. We'll just start with A and then and work our way down. So let's see here. First off, it says that g of 3 is equal to -1. Right? As an ordered pair, that would look like 3, -1, right? So I know I need to have the point 3, -1. Let's start with that. 3, -1. It's got to be on the graph, right? And it's got to be a solid dot, not an open dot, because when the function is evaluated at x equals 3, our output will be -1. All right, first part done. The limit of g of x as x approaches 3, not from the left, not from the right, but just the limit as x approaches 3, so from the left and the right, is +4. Okay? Well, I already know my function value at 3 is -1, so I'm going to need to have an open circle, an open point at +4, and then my graph will be approaching it, that value, from both sides. So it could look something like this. This one could be going down. This one could be going up. I don't really know, but I'm going to do this. I'm just going to, we'll do just out and out for now, okay? We know it's going to continue on somewhere possibly. Maybe more of the puzzle will be filled in later. Part C. The limit of g of x as x approaches -2 from the right, so as we're approaching -2 from the right, is equal to 1. Now, I don't know if the function value is 1. I just know that it's approaching +1 from the right. So as I get to -2, I'm approaching +1. I'll just go with an open circle for now. Maybe I'll fill it in later. I don't know. And it's approaching that. Now, it could be like this. It could be approaching it from below. It could be horizontal. I don't know. I'll leave it horizontal for now until I'm told otherwise. Okay, just then I'll bring it up or bring it down. All right. let's see here. G is increasing on -2 to 3. Okay. So between x values of -2 and 3, it is increasing. Ooh. That's what I have between those two open points right now. So if I take that and I just go, whoop, could be straight, right? That's increasing. It could be kind of curved because that's still increasing the entire way. It doesn't say it's a constant increase or like the same rate of change. It could be curved. It could be straight, whatever. I'll just leave it like that because I've already have it there. Okay? It also could look like this. Right? Look at that. As long as it's increasing the whole time. Okay. Oh, wonderful. I guess we're going with the straight line. All right. The last one, the limit as x approaches -2 from the left is greater than the limit of g of x as x approaches -2 from the right. Okay. So the limit as it approaches from the left side is larger than the limit as it approaches from the right side. Well, the limit as it approaches from the right side is +1 right there, right? So I just need to be larger than that. So what if I were to pick a point, any point above that, say 5? I'm going to make a better circle than that. Okay? All I need is the graph approaching that. Now the limit as the limit of g of x as x approaches -2 from the left is larger than it is when it approaches from the right. And again, this could have been coming like this. It could have just been a horizontal line. It could have been, right? It's still approaching that point. So I'll just make it something nice and simple. I'm gonna go curved on this one though. And let's say, it could be going off forever in that direction. Now there was nothing indicated about anything past 3. So really I could just throw an arrow on this. I'm just gonna go to the right. So let's go back through this and make sure that we hit everything. Okay. G of 3 is -1. That is the case, right? We did that right there. Cool. The limit of g of x as x approaches 3 is 4. From the left and from the right, it's approaching 4. I'm good to go. So, part C. The limit of g of x as x approaches -2 from the right is +1. So from the right is right here. It's hitting +1 for my y value. We're good there. G is increasing from -2 to +3 for my x values, right? I am increasing along that stretch. It's going up. Cool. That's good. And lastly, but not leastly, the limit as g of x as x approaches -2 from the left is larger than the limit of g of x as x approaches -2 from the right. Boom. It's 5 from the left. It's 1 from the right. We are good to go. And one thing to note is that this, there we go. That's what I want. This guy could have been anywhere along here as long as it is above 1 where it ends there. Also, that could have been a closed point. Either one of these, this one or this one or the other, could have been closed. We don't have to have a value there. We could also have had, say some value here or down here if we really wanted. Perhaps there would be, it would say part F here and would be g of -2 equals -3. Now we're good. Another stipulation, right? But there was nothing there. So we really don't need a point here if this isn't here. We could leave it totally open. Or we could close one of them. Look at it. How fun is that where there's like not really a perfectly set answer. These are so fun to grade, by the way. They're so fun to grade from the teacher point of view, but they're great thinky problems. All right. Hopefully you guys enjoyed that. I'll stop rambling. Have a wonderful day. America, freedom, rock and roll, Costco, Riverdog, Jenny on the Gram, and of course, Yo-Ro, you only round once. For mathematical accuracy, of course. Have a great day. Good luck on the practice problems. Peace.